Real exam question. This is question 58 about slab design with yield lines. Determine the maximum bending moment in the X and Y directions of a rectangular slab with sides A and B, where A is the X direction and B is the Y direction. The reinforcement in the X direction is mu times the reinforcement in the X direction. The slab is loaded with a uniform load of Q kilonewton per square millimeter in ELS persistence. Apply this formula to a slab with a length B equal to 1.4 times the width A, and the reinforcement in the X direction is only 60% of the reinforcement in the X direction. So we look at the rectangular slab, simply support on all sides. The width is A and the length is B, and A is the X direction and B is the Y direction. We know that the reinforcement in this direction, it's reinforcement corresponding with the bending moment in this direction and the reinforcement cross-section, the needed reinforcement. So in the other direction, it's mx and the reinforcement that is put in position in this direction. And we know that my is equal to mu times mx. We first start with the axis of rotation, which is situated at the supports of the slab. When two axes of rotation crosses, the yield line starts under an angle of 45 degrees because both end conditions are the same. Do that in the four corners. And then we got the yield line pattern. The work done by the external forces is A times A over 2 divided by 2 multiplied by the load Q and multiplied by the mean deflection, which is delta over 3, and we got this 2 times. Then we have we have four triangles left, there, 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 and there. And for one triangle, it is A over 2 times A over 2 divided by 2 multiplied by Q, and the mean deflection is delta over 3. What's left is a rectangular part, which is this side, which is of course B minus A over 2 minus A over 2 multiplied by A and times Q, and the mean deflection is A over 2. So simplifying the formula, we obtain this equation. The work done by the internal forces around this axis, it is this bending moment in this direction. So it means it's my times A times the angle of rotation, which is delta divided by A over 2. And we got that 2 times. Then the yield line, like this, projected on this rotation axis. It is B times, of course, mx times the angle of rotation, which is delta divided by A over 2. And we got that 2 times, one here and one there on this axis of rotation. We know that my is mu mx, and simplifying the equation, we obtain this. Now E is equal to D, so we get m out of it and mx out of it because everything is now expressed in mx. And this is then the formula. So the mx bending moment is q squared over 24 times something which is only dependent on the geometric characteristics. And then my is of course mu times mx. Now we will apply this formula on a particular case when mu is 0.6 and b over a is 1.4. So now it's easy to calculate the bending moment in the x direction. It's qa squared over 15. And the bending moment in the y direction with mu 0.6 and b over a 1.5 then mx is q8 squared over 25.